Hello everyone, welcome to the world of SANGAM Aryabhatta. SANGAM is a great place to find yourself with rich services providing enhanced solutions. This is why we recommend using Aryabhatta. Aryabhatta is capable of providing a vast number of solutions in the world of advanced machine learning. Today we are going to discuss our product capabilities in building strong classification models for different domain-based applications. Hey Jessica, how are you doing?
I am good, John. What about you?
I am great, Jessica. Thanks. The weather looks so nice today. What have you been thinking though?
I have been thinking about building an intelligent model which could help me identify hundreds of food-related items that were captured by the high-resolution digital cam in my supermarket.
Hey Jessica, I have a solution for you. The solution is Aryabhatta.
Aryabhatta.
Yes, Jessica, Aryabhatta will solve all your problems by intelligently utilizing those captured images and easily identifies any food item located at any position in your market space.
That's cool. How are you going to do that, John?
Aryabhatta can do anything, Jessica. Let me demonstrate you with an example. Let us start building a model by using a dataset which contains several categories of fruits. Let us go to the well-known competitive website for data analytics, named as Kaggle, where we can find our data for fruits. Do you know Kaggle, Jessica?
Of course, John. It is like a Google for all the data scientists.
Okay, we found the data we want, Jessica. Let us download the data for building the model. This data is a zip file and it has been downloaded into a specific location. This data has a huge number of fruits images which has multiple categories like apple, blueberry, pomegranate, banana, etc. Let's us see what we can do with them, Jessica.
I'm waiting for that, John, and you know that.
Okay, Jessica. Let's initially log in into the page and launch the image classification service, which will take you to the workspace.
Hey John, but this data is a zip file. How would you import it?
Our product has a solution for it too, Jessica. In order to start a new application, we are utilizing a new feature in our product by name Upload Zip File. This zip file has an inbuilt project and label structure with all images data stored inside the file. Select the zip file and import the file into the workspace. Now you can see a project has been created by name Fruits. You can see the project structure shown with all the given categories of fruits as label names. In each label, respective images have been uploaded successfully in the project. Each label has more than at least 400 to 500 images which have been assigned with a respective label name. If you want to build a strong model, make sure you have at least 1,000 to 5,000 images for each label in the project to get satisfactory results.
Why is that so, John?
Because the training process essentially depends upon how many images you are using to build the model. Larger the data, more information will be captured by the model, Jessica. Now start building the model by selecting the build icon and you can see a pop-up open for building the model showing the parameters. Here epoch is taken as 25, train batch size as 100 and validate batch size as 30. Now start building the model by selecting the build icon shown below.
Hey John, can you briefly explain the model parameters?
Sure, Jessica. Here epoch explains the number of cycles a model runs for training the model using labeled images. Whereas the train batch size is the number of sample images you are providing to the model for each epoch, and finally validation batch size is the sample images you provide for validating the model. You can see the accuracies obtained for train sample and validation samples as 99% and 99%. Every time a model is built, model files will be generated and they will be used further for predicting the images.
Why do we need to generate this model files, John?
Because model files generated after training captures all the information extracted pixel by pixel from the input images, provided and stores it inside the model files. So, it has the potential to identify the right fruit item for any given test image.
That's interesting.
Yes. Now let us start predicting. For that, click on the Predict button. A pop-up rises. Here we are using the Browse option shown on the left side. Let me browse for an apple image. Let us see what it predicts. Look, It has predicted as an apple with an accuracy of 100%. Do you want some apple to eat, Jessica?
Sure, John, but how about I chose a pomegranate first?
Okay, Jessica. Let us upload a test image, as you can see a pomegranate image. Let us see what our model thinks about it. Look, the image has been successfully predicted as pomegranate. Do you want some pomegranate to eat, Jessica?
Wow, great, John. I was not really expecting that because pomegranate and apple look almost same, but still, we got pomegranate.
Yes, Jessica. And not just that, it has also shown the next likely predicted fruit item to be an apple because of the same shape. Isn't it exciting?
Yes, John. This surprised me a lot.
Let us predict some more by using the option image URL, where we could paste the image URL taken from any website. Click on Predict button. A pop-up rises and select the latest generated model file for making predictions. Let's us take test image URL for banana. Now we click the predict icon. You can see the image has been successfully predicted as a banana with given accuracies. Hey Jessica, are you satisfied?
Yeah. How about one last fruit? You know I am really hungry.
Great. Now let us test with blueberry image URL by selecting the model file. Now click on the predict icon. You can see the image has been successfully predicted as blueberry with given accuracies.
That's awesome, John.
We can also deploy the model in the cloud services such as OpenShift, Amazon Web Services, Azure, and perform predictions in the cloud environment as we have developed user interface page in the cloud. You need to provide the email address, model file name you want to deploy, and select the target deployment option to where you want to deploy. Here we have selected OpenShift and deployed the model. Check your mailbox and you can see that the Fruits project has been successfully deployed, and you can access these models using the URLs shown. Select the first URL and it takes you the page where you can use the UI in a cloud environment. Select the UI icon and start predicting the test images here. Now select the Swagger for finding the route location for the prediction service. Now let us use this service manually to predict the test images from the Postman. In order to do that, let's first copy the second URL from the mailbox and paste it in the Postman. Then copy the route location from Swagger as shown, and paste the location in the Postman beside the URL. Now provide the input structure in JSON format as shown, by giving the image URL of a pomegranate. You can see the image has been predicted as pomegranate.
I am so blown away right now. This just looks so awesome, John.
Thanks, Jessica. This completes the building of the image classification model on supermarket fruits data, which has started from data ingestion and ended with the deployment of the model in the cloud environment.
Thanks a lot, John, for making my life easy.
Sure, not a big deal, Jessica. This is how we can perform predictive modeling process using our product, the one and only Aryabhatta. Stay tuned for the new exciting applications we are going to build. Sounds exciting, right? Until then, keep predicting. That's all for this video. For any queries, please reach us at vj.ready@sangam.ai.